A stratified model of art history, from cave walls to quantum states. Chapter 6. The binary layer. Exposure of 0 and 1. In the previous chapter, we discovered that a digital image is made of numbers, millions of them, arranged in a grid, each one describing the color and brightness of a single pixel. That was already a long way from a cave painting or an oil on canvas, but we have not yet reached the bottom of the stack. Because those numbers, all those millions of pixel values, are themselves made of something even simpler. They are made of zeros and ones. Every number in a digital image, every color value, every brightness level, is stored in a computer as a sequence of binary digits, what engineers call bits. A bit is the smallest possible unit of information. It has only two states, on or off, yes or no, 1 or 0. That is all. Nothing simpler is possible. And yet, from this absolute minimum, from nothing more than the difference between 0 and 1 repeated billions of times, every digital image that has ever existed is built. The simplest possible difference. To understand why this matters, it helps to think about what a bit actually is at the physical level. Inside a computer chip, a bit is represented by an electrical state. A tiny region of semiconductor material either has a voltage or it does not. Current flows or it does not. That physical difference, present or absent, charged or uncharged, is encoded as 1 or 0. And because these states can be switched billions of times per second, and because billions of such switches can be packed into a space smaller than a fingernail, computers can process and store information at a scale that is almost impossible to imagine. But strip away the speed and the scale, and what you're left with is something almost absurdly simple, a light that is either on or off. This is what the binary layer exposes. Beneath the rich, complex, endlessly varied world of digital images, beneath every color, every gradient, every subtle shadow, lies a system of switches: on, off, 1, 0, the most minimal distinction that the physical world can register and preserve. How zeros and ones become an image. It might seem impossible that something as simple as a sequence of zeros and ones could contain a photograph, a film, or a work of digital art, so it's worth pausing to understand, at least roughly, how the translation works. Take a single pixel in a digital image. It has a color, let us say a particular shade of blue. That color is described by 3 numbers: the amount of red, the amount of green, and the amount of blue light that make up that shade. Each of those numbers might range from 0 to 255, that is 256 possible values. The number 255 in binary is written as 11111111, 8 ones in a row. The number 0 is written as 00000000. The number 128 is written as 100000000. Every value between 0 and 255 can be expressed as a unique sequence of 8 zeros and ones. So a single pixel, one tiny dot of color in an image, requires 24 bits to describe: 24 for red, 24 for green, 24 for blue. A photograph with 12 million pixels requires around 288 million bits. A high-definition film running at 24 frames per second for 2 hours requires hundreds of billions of bits. All of it, every image, every film, every digital artwork that has ever been made, is at its foundation a very long sequence of zeros and ones. Continuity has disappeared. In every previous layer of art history, there was some form of physical continuity in the material of the image. The limestone of a cave wall was continuous matter. The fibers of a canvas were woven together into a continuous surface. The silver particles in a photographic emulsion, though tiny, existed in a continuous chemical layer. Even the frames of a film, though discrete, contained analog images, images in which tone and color existed as continuous gradations, not as a series of steps. Binary is different. At the foundational level of digital images, continuity does not exist. Everything is divided into discrete steps. Colors do not fade gradually into each other. They jump in increments, however small those increments might be. Forms do not have truly smooth edges. They are approximated by a grid of square pixels. Time does not flow continuously. It is divided into frames, and each frame is divided into pixels, and each pixel is divided into numbers, and each number is divided into bits. What looks smooth and continuous on a screen is, at its foundation, a very detailed illusion. The continuity we see is constructed by our own perception from an underlying reality that is entirely discontinuous. This is a direct extension of what we discovered in the cinema chapter. There, we saw that the appearance of movement was constructed from a sequence of still frames. Here, we see that the appearance of smooth, continuous color and form is constructed from a sequence of discrete numerical steps. In both cases, the appearance of continuity is something the human mind adds. It is not in the image itself. Logic as a material. Here is one of the most striking ideas in this chapter, and one of the most important for understanding the world we live in. In all the previous layers of art history, the materials of images were physical substances, minerals, plant fibers, animal products, chemical compounds, light-sensitive coatings, cellulose film. These materials had weight, texture, color, smell. They aged and deteriorated. They responded to heat and cold and moisture. Working with them was a physical, sensory experience. In the binary layer, the material has changed entirely. The material is no longer a substance. It is logic. The operations that process binary data, the and, or, and not gates of Boolean algebra, the fundamental building blocks of all computer circuits, are not physical in the way that oil paint or photographic chemicals are physical. They are abstract logical operations implemented in hardware. The artist working with binary data is not mixing pigments or exposing film. They are defining rules, setting up conditions and operations that will produce a certain kind of output when certain kinds of input are provided. This is what it means to say that logic has become a material. The stuff that images are made of is no longer something you can touch. It is something you can reason about. And the skill of making images has been joined, not replaced, but joined, by the skill of constructing logical systems. Making the invisible visible. Most of the time, the binary layer is completely hidden from us. We look at images on screens and we see colors, shapes, faces, landscapes. We do not see zeros and ones. The entire purpose of the technology, the screen, the graphics processor, the display software, is to translate binary data back into light, quickly and seamlessly enough that the underlying structure is invisible. But artists have found ways to expose that underlying structure, to make the invisible visible. When an image is compressed too aggressively and the compression artifacts become visible, the blocky, pixelated distortions that appear in low-quality digital images, we are seeing, in a crude way, the consequences of the binary layer breaking through the surface. When artists deliberately pixelate or glitch their work, they are choosing to expose the grid, the discreteness, the underlying structure that is normally concealed. This gesture, the deliberate exposure of a hidden structure, has a long history in art. Late Impressionist painters made their brushstrokes visible, refusing to hide the process of painting beneath a smooth surface. Cubist painters exposed the underlying geometry of form. Film editors sometimes made their cuts deliberately jarring, breaking the illusion of seamless continuity. Exposing the binary layer is the contemporary equivalent of these gestures. It says, look at what this image is really made of. Look beneath the illusion of continuous, natural-looking reality. Here are the seams. Here is the grid. Here is the 0 and the 1. The infrastructure of images. The binary layer also invites us to think about something we rarely consider: the physical infrastructure that makes digital images possible. A digital image does not exist in empty space. It exists on a hard drive, or in a memory chip, or on a server in a data center. Those servers are real physical objects, enormous buildings filled with computers, consuming vast amounts of electricity, cooled by industrial air conditioning systems, connected to the rest of the world by cables running under oceans and across continents. When you look at an image on your phone, that image may have traveled from a server on another continent, through undersea cables, through wireless networks, through the air to the small glass rectangle in your hand. The binary data that makes up the image has been copied, transmitted, decoded, and displayed dozens of times in a fraction of a second. None of this is visible in the image, but it is all there, underlying it. The binary layer is not just about the logic of zeros and ones. It is about the vast physical infrastructure that those zeros and ones require in order to exist and travel and be seen. In this sense, the data center is the cave of the digital age, the physical place where images are fixed and stored, hidden from sight, accessible only to those who know how to reach them. The minimum beneath everything. We have now traveled a long way from the cave. From mineral pigment pressed into limestone, to oil paint on stretched canvas, to light fixed in chemistry, to time captured on celluloid, to images converted into numbers, and now to those numbers themselves reduced to their most basic form, the 0 and the 1. And at each step, the previous layers have remained beneath, still present, still active, still in use. The binary layer is not the end of this journey, but it is its deepest point so far, the most abstract, the most minimal, the most removed from the physical world of stone and pigment and light. It is the point at which the image has been reduced to the smallest possible difference, the difference between something and nothing, between on and off, between 1 and 0. And from that minimum, as we have seen, everything can be rebuilt. Every color, every form, every movement, every face, every landscape that has ever appeared on a digital screen, all of it assembled, pixel by pixel, number by number, bit by bit, from the simplest possible foundation. The cave artist pressed pigment into stone with their fingers and left a mark that lasted 30,000 years. The binary digit is pressed into semiconductor material by an electrical charge and lasts as long as the power holds. The gesture is different, the material is different, the scale is different, but the fundamental act, fixing something in place so that it can be seen again, is the same act that began this entire story, deep in the darkness of a prehistoric cave.